Okay, so today we'll be talking about properties of exponents, specifically in regard to the 8th grade standard that reads, know and apply the properties of integer exponents to generate equivalent numerical expressions. So the first theorem is that a to the n plus m equals a to the n times a to the m for any numbers a, n, and m. We can write this as a times itself, n plus m times, by the definition of exponents. We can then split this up to be a times itself, n times, multiplied by a times itself, m times. Then we can see that this equals a to the n times a to the m by the definition of exponents. Now theorem 2 states that a to the n divided by a to the m equals a to the n minus m power. We can write this as a times itself, n times, divided by a times itself, m times. Now there are 3 cases of n and m to be considered. First, if n is greater than m, we can write this equation as a times itself, m times, multiplied by a times itself, n minus n times, all divided by the same denominator as before. Now if we divide the m amount of a's out of the numerator, the fraction reduces to a times itself, n minus m times. And by the definition of exponents, this just equals a to the n minus m power. Now for the second case, what if n was equal to m? Then a to the n over a to the m will just equal a to the n over a to the n, or likewise a to the m over a to the m, which clearly equals 1, since we have a number being divided by itself. The last case is when n is less than m. We do the same as before, except this time we'll split up the denominator. Now if we divide the numerator by the n amount of a's in the denominator, the fraction reduces to 1 over a times itself, m minus n times, which equals 1 over a to the m minus n by definition. This can be written as a to the negative m minus n power, and if you distribute the negative and swap the variables, we get a to the n minus m as desired. And this is since 1 over a to the x equals a to the negative x for any number x.